on the need to knows. So typically on the AP test, this is going to show up as a question, and I will have one photocopied for you for Wednesday. We're going to do an in-class, little like 15-minute AP. The first question will ask you to find the area of the bounded region. The second one will tell you to rotate it and find the volume. The third one will do uniform cross-section. And then the fourth one will be to find the perimeter. And so normally like 2 of the 3 perimeters are straight lines, and then 1 is a curve. So you would use arc length to find the length of a curve is what arc length is doing. Okay, so there are 2 formulas, but it just depends like which way you're doing your cuts. So in essence, it's the same formula. Okay, so the formula for arc length, so they use L for arc length. So if you are doing dx cuts, your limits will be x equals, you guys, it's glorified Pythagorean theorem. Okay, they run through and then they do all the division and stuff. I'm just going to give you the formula because most people don't care where it came from. It is going to be 1 plus your derivative of the function squared.
This is today's lesson. So that's all it is.
And if I'm using y limits of integration, then it's my derivative with respect to y squared, and then it'll be a dy out here because there are all y's in there.
Oh my gosh!
Wow, this is really hard.
It's the algebra. I'll be honest, your algebra skills will, once again, be the piece that brings you down. So your derivative with respect to y, and this will be dy's. I'm going to do 2 just mostly to make sure your algebra skills are solid. That's our big reason. Make sure if you put out your formula sheet that you add this onto the need to know formula sheet. There's one on there for arc length, okay, and with respect to x or with respect to y. So make sure you have arc length added onto your need to know sheet somewhere. Okay, this is still in the AB part. It's not on the BC only sheet. This should be on the AB portion.
When do we turn BC?
When do we turn BC?
Yeah.
We turn BC at the end of this chapter. We're done with the AB curriculum at the end of this chapter. But it's why people who don't go on don't get the AB credit is because what we've done since then, finishing integration, doing our numerical techniques, and then all of the area volume stuff are like cornerstones for AB calculus.
I just don't understand how does, because I heard that those, I think they're on chapter 6 right now.
I know.
How, what do they fill the rest of the year with?
I tutored a girl who went to Pondo, and we were like almost at the same spot for most of the year. I'm like, I don't understand the point of
Like,
cramming
do they
that
just
in.
keep doing the same lesson over and over?
They probably just repeat them.
But still, like, I don't understand the point of like cramming it so fast when, I don't know. Yes.
I don't know. So we're still on AB. That means BC's only going to take till spring break.
It's part of why I don't break it. BC's only 3 chapters.
Oh.
Wow!
What?
People
So-
have separate classes? Wow.
How do they take a year
What do
class
they do with a full year in 3 chapters? Are
They have to
hard
go back
chapters?
over because now you guys think if you went all summer with no calculus,
No.
now you have to come back. And their pre-calc, they don't teach vectors, polars, or parametric in pre-calc because they have time in Calc BC to teach that. Well, I don't have time to save all of that for Calc BC, so I teach that in pre-calc.
That's
So-
a waste of time.
So they have to go back and review AB stuff, and like you need to be really good at derivatives and integrals for Calc BC. So they have to go back over that again, and then they have to introduce polar parametric and vectors, and then they have to do the calculus to it. So they have to fill in stuff that I teach. I'm like the only one that teaches some of that stuff in pre-calc, but it's because I don't have time to do it during Calc BC. I would rather review for the AP
I
test.
feel like we're way more efficient.
What are the 3 chapters? Are they really long, hard? It's like
One is really easy, one is really hard, and one's medium.
Well, that's funny.
All right, here we go.
Yeah. Well, we kind of coast.
What would
Find
you
the arc length of the graph.
That's the point. So it's slightly different.
What do you think has been the hardest chapter so far for us?
This will be one of them, and then usually the word problems, the max min related rate, just because it's word problems. All right, so we are finding the arc length for this curve on the interval. So when they say on the interval, what values are these?
X.
Those are x values. So when they say on the interval, and the bracket means they are included. Okay, so it does not matter. This problem pretty much works out the same either way. First of all, let's get a graph going. It doesn't matter which one you solve for. For me, it's easier to solve for x because I just have to square root both sides, but it really doesn't matter. Make an xy chart. You know your x's are going from 0 to 8, so get values to graph from x equals 0 to x equals 8. Actually, I'm only going to plug in x equals 0 and x equals 8 because when I solve for y, my x is to the 2/3 power, so I need to, remember you guys, this means root, so I need to be able to take the cube root of the number before I square it. So I've got 0 that I'm going to include, 1 that I'm going to include, and 8 that I'm going to include because those are the numbers that I can take the cube root of. So that's how I'm choosing my numbers.
For some reason, I always forget that it's the bottom one that you.
So it's the root to that power.
Then when I learned this, someone told me that it didn't matter which one you did first.
Well, you can square the number first and then take the cube root at the end, but the issue is like 8 squared is 64, so then to take the cube root of that is a little bit more thoughtful
That's true.
versus the cube root of 8. So I make the number smaller first, especially if it's a large number like 125. I don't want to square 125 and then try, but I know that the cube root is 5, and then I can do it. So I make the number smaller first, but it's a personal preference. Yes.
So it actually will solve regardless either way. Right?
Yes,
It has
it's
to.
just you're going to sometimes make it to where you can't solve it without a calculator. So like my example of 125, you're probably not going to square 125 and then find that cube root without the use of a calculator.
Yeah.
So that's why I make the number smaller first and then raise it to the other power. So you guys, my x and y limits are both happy, okay? And if you look, we've got both of these. It does not matter which one you choose, as long as you use the limits that go with that particular function, it will work itself out for you. Okay, so a graph, it doesn't need to be a great graph. You are at 0, 1, 1, 2, and 8, 5. Okay, so they're asking you to find the arc length for that curve. So you guys, I have solved for both x and I have solved for y. So remember, we have to take the derivative and then square it. Which one of those do you want to take the derivative of and then square it? Yeah, I'm thinking x to the 2/3 because when I take the derivative, it's going to knock off this plus 1. And then squaring that's going to be very happy. Compared to this, you would need to use the chain rule for that derivative. Okay, so as I'm doing them, if you solve for both, usually there's one that's like, oh, I definitely would like to use that one. Okay, so I'm going to use this one. You need to find its derivative. We'll square it. We'll run through the formula. It's basically, today is an algebra day. Do not just type these into your calculator. Make sure you can do the algebra steps.
2/3.
Okay.
Ay, ay, ay.
It's one of those Monday then.
Great question.
Whoa, I just took the antiderivative.
I did the same.
I totally just took the antiderivative.
Well, I combined the two.
Yeah, this is what I did this prior.
What did you do?
That was great.
Yeah, definitely.
I think I'm
Today's a
just
good
so much
day.
girls.
Now am I
Yes.
right? Okay. So I am using x's, so I need my x limits of integration. So I'm going from 0 to 8. So I'm going to integrate from 0 to 8, square root, and I'm going to remind you that these are x limits. So it's the derivative squared. So square this, and square that. So x to the 1/3 squared is x to the 2/3.
I don't like this. I don't understand how you find the perimeter with this.
It's that you're doing little itty bitty Pythagorean theorems.
Oh, okay.
Okay, so like a little itty bitty Pythagorean theorem, and this is your dx, and this is your dy, and so then they solve. So if you did dx squared plus dy squared equals that, so the square root, and then they divided. So instead of dx squared plus dy squared, they either divided both by dx squared or both by dy squared, depending which derivative they had. Okay, so it started as okay. And then whichever one. So we did dy dx. So if you divide both by dx squared.
Awesome.
So like glorified Pythagorean theorem kind of.
Yeah.
Okay, does that make more sense to you? Okay. All right, you guys. So you have a fraction and something that's not a fraction. We are practicing algebra skills. What do you have? Common denominator. So let's do that.
Screw those.
Okay.
Okay.
Dang it.
That's fun.
I'm gonna have to do like this antiderivative with my hand too.
Stop.
Hey, you guys hanging? No. So I told you guys today the formula is super easy. The algebra is thoughtful. Okay. So now, if I have a square root of stuff on top and square root of stuff on the bottom, you are legally allowed to separate the square root to the top and the square root to the bottom.
Oh man, this is.
It's gonna be great.
I don't know about that. But
It's also soft.
This is the stuff that takes me like hours to figure out.
yeah.
Oh wait, is it D? No.
AX.
You don't have to use it or anything, right?
We'll get there.
You do, huh?
Shoot!
Well, because I think
Okay. So now look. This single denominator, by design, is going to be a perfect square. So those of you that are talking through me, you're going to be sad when you try to do this by yourself. Okay, you took a derivative and you squared it. Okay, so by design, that piece that's in the bottom is going to be a perfect square because it started as something squared. So you can take the square root of 9, which is beautifully 3. When you take the square root of x squared, or x to the 2/3,
it cancels out the two.
it cancels out the 2 and puts you back at that x to the 1/3. So please notice the square root of this is my 3x to the 1/3. So like there are pieces that should actually help you. This is what I used to square it. So when I'm taking the square root, it should put me back. So those are at least pieces that should help you. Okay, so keep going. I'm going to pull the 1/3 in front. You can leave it there if you would like. Hey, Kaylee was the one who suggested this, and you guys are going to love her for it. Are we going to have to do a U substitution? There are two ways these problems will finish. Either the stuff on the inside, if I let it equal U, its derivative will give me a form of the outside. So when I say a form, you guys, ignoring everything else, x to the 2/3, its derivative is 2/3 x to the negative 1/3. And please notice, okay, so that's one way it can end, is that it's going to be a U substitution. The other way that it can end, which will be the next problem, is the stuff on the inside will factor to where the parentheses are identical, so that I can write it as a parentheses squared underneath the square root. So those are the only two ways these problems will finish. Right? So if you only have two things, this is not going to be factoring. So this is going to be a U substitution. When you have three things, it should factor into a perfect square and then finish up. Okay, so we're going to have to be creative. So I'm going to rewrite, what I'm going to do on this front is I'm going to rewrite it as a 1/3 x to the negative 1/3 so that it lines up a little bit better. You can pull the 1/3 in front if you would like. Yes?
Do we do it 0 to 8, 0 to 3?
Yeah.
Okay, I got so confused. I was like,
I thought you were like tying in the 1/3.
I had the 3 and then the 8 and it's Monday. I don't know what else to tell you. So some of you will pull the 1/3 in front so you don't have to deal with it. I don't actually care. For me, it's easier to move the 1/3 in front, so then when I'm trying to get my U to match, I just have to multiply by whatever's there. So this is easier for me to write it like this. Okay, so I'm going to stop. You guys try to do your U substitution to see what you can get. So your only two choices are U substitution. If it's 2, or if it's 3, it should factor into a perfect square. The reason why I chose to move the 1/3 in front was so that I just needed to get it down to x to the negative 1/3. So then I'm replacing x to the negative 1/3 dx. That whole thing gets replaced with my du. So that 1/6 is going to end up out in front with my 1/3. That makes it easier for me. If that doesn't help you, then you do your U substitution however you would like to do it. When I switch to U's, you guys, I take my limits off because those are X limits of integration, not U limits of integration. I don't want to be tempted to start to plug in 0 and 8 when I still have U's. I just need to make sure it's right. Like somebody needs to give me like,
Yeah,
yes, that's where I'm at.
Yeah.
Okay, thank you. I feel like I'm having a really bad math day right now.
Yeah.
Having a bad math day and being a math teacher would suck.
It's okay for the other classes because they really require very little thought. But calculus, like I actually have to think as I'm doing it. So it's all a little sketchy right now. All right, here we go.
Oh man.
So I'm gonna leave that 127th for the very end because I don't think it's gonna be my friend. So 8 cube root of 8 is 2. 2 squared is 4.
Like the
3
4
is
over
40
the
the 8.
What?
What is 40 to 3?
Oh,
I'm just gonna leave
God.
that. I'm leaving 40 to 3 halves because you cannot take the square root of 40 evenly. So I'm just going to leave it. But the other one you can't. When you plug in 0, this is gone. So you have 4 to the 3 halves. That you can evaluate. You can take the square root of 4 and then cube it. Is that not the most beautiful answer you've ever seen in your life?
Oh, so you can just leave it like that.
On a non-calculator, absolutely.
Okay.
There was a problem one time on the AP test, and I was so irritated because usually the numbers work out nicely, and it was like the 5th root of 12. And I felt so sure that I had done it incorrectly when I was working through the answers because it was crazy. There are times they'll just have crazy answers. If it's something that can simplify, take care of it, but then just leave whatever's not. I'm telling you, I told you guys last week, the actual equation is not difficult. The algebra to finish is difficult. This will definitely be non-calculator. Okay, so practice your algebra today. So choices are, you have 2 terms under the square root. You're going to have to rework it so that it's a U substitution. The next problem we're going to do, we will have 3 terms underneath. They will factor into a perfect square. Okay, so let's do the one where we have 3 terms, and then that's our last example, just because it's all algebra. All right, so the equation, find the arc length of the graph, y equals 1/6 x cubed plus 1 over 2x, so the x is in the bottom for this one, and we are on the interval. Okay. On the other one, we could have, in theory, done dy's and gone from 1 to 5. But this one, your only option are x's. So see where you can get. You know you have to use x's. They gave me the x limits. I don't even really need to graph it unless I'm just feeling like extra energetic because I can only use x's. They gave me the x's. Okay, so go through. You're going to have fractions. You're going to need common denominators. Okay, so go through and do your integral. 1 plus the derivative with respect to x. And they told you your x limits. Okay. Take your derivative. When you square that derivative, you're going to have a plus sign or a minus sign in the middle, which means you are not distributing your exponent. How are you going to square that?
Foil.
Foil. We are going
I have no
to
idea what you're talking
foil
about.
that.
All I saw was like the hand signals.
Yep, that's foil when there's plus or minus on the inside, you guys. Today's an algebra day. The calculus is crazy easy. The algebra is thoughtful. Work in your group. See if you can get it.
Yeah. Oh yeah. I did. Did you like it? Minus 2 somewhere?
Yeah, but it's still on the bottom.
Before that, I have the square root of 1 plus is 1/2 x squared minus 1 over 2x squared. Minus 6? Wait. I got like minus 2 2x. That's what I got.
Okay.
Oh yeah. You know what I did?
I got 2/3 minus the x to the 5th over 20.
Whoa.
What's up?
Prior, can you not have? Why? I'm just wondering.
Did you guys get this one? You guys followed it?
If you had,
Okay.
can you change the equation to?
Sounds good.
Oh wait.
You should go. Oh man. This hurt my head.
You have to ask me a question, Maddie.
What? No. Never mind.
Yeah.
Did you say you have to or do you?
Well,
have
she
to?
keeps asking me, like, but there a question isn't coming out, so I can't help if there's not.
I'm not sure if I did the antiderivative chain rule right, but like, so what I did, so I got like the middle of the square root thing, and I took the antiderivative of that, and then took the antiderivative of the outside. Why did you say antiderivative? When you're integraling it. Integraling? Whatever. Integrating? Integrating. When you're integraling it.
I don't usually comment on anybody's English, but that was just sweet. All right. When you're integraling it, stop it. I'm not even there yet. I'm still squaring my derivative.
How are you there yet?
Did you square your derivative?
Maybe I did the derivative wrong.
Do you have 1/2 x squared minus 1 over 2x squared?
Oh god, this is
Horrible.
No.
I left my 2 on top for some reason. That's why I was like,
Oh, I did it wrong.
Okay.
Yeah.
I'm gonna keep going.
It's just a 1. It's not a
Dang it.
oh.
What?
I got that.
I think I got that.
I just wanted it to
Oh
be
my gosh, I
happy.
actually did get that. Where'd the X's go?
I did 1/2 x
Yes.
squared minus 1/2.
Oh, they just
cancel
because
because
it's
x squared over 2
Yes.
multiplied by 1 over 2x squared, so it cancels.
I don't know.
That's fair. I was like, where'd you get the 2? Oh, where'd that come from? It's a little fraction that goes together.
Hello.
This is fun.
Okay, now I still have to put it into the radical with a +1.
Don't tell me about it.
What's 1 minus 1/2? 1/2. Yes.
Is this just one that factors?
So your options are, if there are 2 things on the inside, it's going to be a U substitution. If there are 3 things on the inside, it's going to be a factoring one. But I'm still going to stick with all of my other stuff of common denominator, separating the root on the top and bottom. Okay, so I'm going to take care of that before I do anything.
Are you gonna combine the 1/2 and
Absolutely.
Oh, this is painful.
I told you it was an algebra day. It is not a calculus day.
Yeah, I know.
Me
It's
too.
not my thing. I think that algebra is why I can be a math teacher.
Now we just all
Yeah,
get
the
it
algebra
together.
thing's
The
pretty.
algebra, I can do all the calculus math. But it's like the 2 squares.
Bring it on.
The algebras was messing me up all the time.
Stop, don't write that.
Just your subconscious trying to make it happy.
It would be
It'd be
nice.
so happy.
Wait, you all still.
Okay, so I'm going to stop for a second and make sure you get to here. From here, common denominator, separate the root from the top from the bottom. So all of those steps are the same as the last problem. The bottom will be a perfect square. You can pull it out. The top will have 3 terms. When it has 3 terms, that is always when it will factor into a perfect square. Okay, so see if you can now make it happen.
So we just now just
Common denominator, square root top, square root bottom. So the same steps on this, the last problem.
But I just did it.
All algebra.
I know.
I got my top.
It makes me feel bad.
Common denominators, you guys.
X to 8 plus 2x to 4.
Is that
That's what I got too.
Yeah. Hey, is it?
Yeah, that's what I got.
Okay, cool. That is not after I integrated it. That is before. How are you at the integrating part? Oh my god, what am I doing wrong?
I don't understand. No, I just say ask that because I don't know what I'm doing.
No.
I think somebody else was like that. Steve. Yours is really great.
Oh, that would be.
I know, it's really helping my self-esteem right
I'm
now.
doing.
Oh man, okay.
It's helping me get through the day right
So
now.
have you tried to do a common denominator? Like, you guys need to make efforts on this, otherwise you're totally out of luck on your chapter test.
Oh my
I
gosh.
got that part done.
That's not helpful.
Just.
Times x.
We're making it 4x to the 4th. That is my problem.
Really?
So,
Yeah.
I'm making x
I actually got that part.
Okay. So now that.
Okay.
Let me see if I got this a little bit. So you got
2x to 8, or x to 8 plus 2x to
Yep,
4
those
plus
Yeah.
1. Yeah.
minus 1?
Plus 1.
Woohoo!
You should plus.
Why did I do
Yeah.
that?
That.
Oh, that's a plus.
It's 2. You have to do the 2.
I just don't know where to go.
Actually,
So I just took the square to the bottom, and I'm trying to figure out what would foil.
well, you
I
can
was
do
at the
that.
bottom 2x squared.
I
So
got this,
it would be.
guys. So,
You can't take 2 out of 1 and leave it as
So
1.
I'm guessing the top would be the square. It's x to the 4th and x to
Okay,
the
you guys check. When you do a common denominator, okay, to make sure I didn't think that this x to the 4th was on the bottom, that's why I erased it. I drew my line really big and made sure I remembered this x to the 4th was on the top. So this bottom had the 4, but not the x to the 4th. So I multiplied top and bottom by x to the 4th. The next one has the 2. It needs the 2x to the 4th. This one does not need anything. This bottom is a perfect square.
2.
I just got lead in my eye.
This top is also a perfect square. So out here I'm going to write that I separated this top, x to the 8th plus 2x to the 4th plus 1. That factors. When you have 3 terms, it will factor and the parentheses will be the same. They're set up to be happy. 2 terms, it will be a U substitution. 3 terms, it's going to factor. So this factors into what?
X to the
X
4th
plus 1 plus 1.
Woohoo.
So like, what
That gives you x to the 8th plus an x to the 4th plus an x to the 4th is your 2x to the 4th.
So basically, if you end up at the end and you don't have a perfect square,
You did something wrong.
Okay.
It always cracks me up when people, I'm like, no, I was totally explicit. 3 terms, this will happen. 2 terms will be a U substitution. Like, we live in a happy mountain.
And if neither of those happen, then
You did something wrong.
That would suck to get thrown on a test.
Yeah, I know, because you've already done so
I'd
much.
be so mad.
Okay, so now you guys, are you at the x to the 4th plus 1?
Yes!
Okay, so,
I got there.
now what?
I have no clue.
Oh my god.
Okay, I feel like what you would do is take.
You can't do a U.
You have to do the D, V, D, U.
Do you really have to? Oh, I
No
was
wait,
gonna say.
couldn't you take that bottom and multiply it by the top by a -1? Do you know, like,
What?
move that bottom part to the top in parentheses, and then have it to the -1 power, and then you can just take the derivative of each one separately?
Oh.
No,
But you
no,
were
because it'd be
close.
multiple. Okay, I was close.
How about we do this?
Oh, and they'll simplify down. Oh my gosh.
And this plus that. Okay, so what you were practicing
Oh, that's what I
today,
meant, not multiplication. I
See?
meant adding, sorry.
what you were practicing today, honestly, is algebra. Okay, the calculus is pretty minimal and pretty straightforward. The derivatives are generally not crazy, now that we remember how to do derivatives. The integrals, as long as you know where you're going, are not crazy. It's all the algebra in between. So, if you're the person and you type it into your calculator every single time, I am just telling you will not get this right on the non-calculator. This is not a problem to walk in and be like, oh, I'm sure I can do it. I'm not going to practice it. I guarantee your algebra skills are a little sketchy.
I'd say mine is sketchy.
I swear if that ends up, oh my god.
Okay, now go for it.
It ends up
This is where how it's easiest for me. You figure it out. It's easiest for me to write it as a 1/2, and then the x squared, and then this is a 1/2. But instead of putting the x squared on bottom, having the x to the -2, that's easier for me to integrate. Okay.
Oh, the top of the first one.
And remember, you guys, our big calculus piece was our derivative, and now we're finally to our next calculus piece of integrating. So each calculus piece is not bad.
That's almost the same as what we started with.
Bless you.
What's your Wait, this is it's the exact same except for a plus and a minus.
Why?
So not for any reason
I know.
that's ever going to be consistent.
Not
I
doing
know.
it right now.
Did you get it?
Wait, isn't it 1/6?
Look at one
Yeah,
six
I
to the
got
third
it.
minus 1 over 2x.
I did
Yeah.
not agree.
I just
Yeah.
did x to the -1, but I showed
Okay,
it.
so then after
So it's
that,
not
We plug
negative.
like 1/2 in too.
yeah, what did
Let's do 8/6.
Why did you do
eight
this
over
to me?
6 minus for 1/4, right?
You know what the worst part is when I mess up
2
plugging in
thirds,
together
yeah,
for
minus
an
1/3.
antiderivative. That's where I mess up
Oh,
a lot.
minus, okay.
Oh man.
1/2.
What is
1/2.
8/6?
1/6 times 1/8 is 1.
Oh my goodness. This problem on the test.
What is
Bring it, Miss Fryer.
6 times 8, 48.
It is.
Oh my gosh!
Isn't it 1 over 148? Or 1
It's
over
1 over 48 minus.
what's minus 1/4?
How'd you get 48?
But the 2, no, because the 1/2 something bought, it's just 1. Because what's 2 times 2? If you plug in 1/2 where x is,
What is
2 times 1/2 is 1, and then it's just
Oh
1
yeah,
over 1.
you're right. Just kidding.
Oh. Oh my gosh, I was doing this
It's
before.
not like no.
Stop.
Okay.
Not today.
Okay, so
Can I just leave it like that, or do I have to common denominator all of them?
Common denominator them.
Why?
So.
You minus 1 or you add 1?
Okay, 59.
Where'd you get 59 over
I don't
48?
know. I don't know where.
148 minus 48 over 48.
how do you get 6 to be 40?
I don't know how you did that.
Yeah. So,
You're either having a really full calculator and then just what I do.
We need it after today.
I know.
Yeah.
Wait.
Not. 2 plus 11. Oh.
Did Melania ever pass those out for us?
We looked at them and then he.
What are they?
We're on
Cool.
simplified.
I don't know.
Is it for another ice cream party?
Yeah, where are they?
Oh.
I'm not working on it. I switched for today. So
What's 16 minus 13
no, I never have been.
minus 47
I just passed those
over
switches.
48?
Yeah, and that's how I
Makes
got.
me feel
Wait,
smart.
that's plus 47 over 48 because it's a negative. What is 12? It's 13 times 4.
No, I don't think that's 4. No, it's not. Actually, there's what is it, 13. Yeah. 52.
Okay. Well, it's whatever 52
You
plus
get
47,
43.
which is 99. Okay.
Ooh, I did something wrong.
Was it close to
So it's just 99 over 48.
8?
Divided by 3.
Is that an 8 times?
Oh.
Oh my gosh, wow.
Well,
Wow.
so wait, did you guys get 40, 33?
So it's 33 over 16.
Holy poop.
Okay, cool. Oh, this.
76.
Wait. Oh. 2
half.
The
I
x is
did
on the
not
bottom.
get that.
2 times Here,
Like
wait.
half is 1.
Oh, so.
Dude, not.
I got that much. I did get this much, and then something got lost in translation.
Oh, I like that movie.
I was about to say, I really like that movie.
Oh, I did.
All right, kids, there's some beautiful fractions for you to stare at and
Can
learn.
I go back to kindergarten now?
I know.
1 and 1. All I want to know how to do.
Remember just thinking, man, multiplication really sucks. And I'm just here, I'm just like, no.
I'll take multiplication over addition.
Now I understand.
Okay, on one of our tests last term, I definitely said 3 squared was 6. So, that was my life.
I definitely wrote down once that a 1 plus 3 equals 5.
It's not a good class for algebra.
That's not even algebra.
Hey, did you guys bring t-shirt money?
Yes. That's bad.
Oh, did you guys bring my money for chance?
We'll bring you.
I have
some.
$1. I'm okay. Wait, so what are we deciding
might have
to do
actually.
about ice cream?
Yeah, wait, guys. Would you guys rather, since we're bringing all these toppings and like brownies and stuff like that, and I know you got like marshmallow things, would you rather just get like a huge tub of vanilla ice cream, or do you guys still want the special vanillas?
I'd rather just get
Yeah, I think vanilla's enough.
Okay, then it's gonna be more expensive, so it'll be way cheaper.
way cheaper.
Because I can get it. Well, I can get it with a discount. To get it at Safeway.
But you get it's like $6 for
Yeah.
a huge fat tub
Yeah.
of ice cream.
Yeah, it's way cheaper.
It's way cheaper.
Do you want? I'm going to Safeway today.
What size shirt?
If you want to get it, sure, I'll give you them. I'll also get Lauren's because I still work tonight, so I'll get yours.
All right, you guys. I'm gonna put your stuff on the sideboard. Also, I'm putting up the whole review stuff. Test is not until Thursday, but then you can spread it out for however you need. And then your packets were over there. Make sure you grab your packets from last week.
And if I get Safeway brand ice cream, I get 10 cents.
Whoa.
Yeah, I would get Safeway brand.
Safeway branding is good. Like, it's
No, it's actually pretty solid.
It's all the same. I think it's just the only one that I actually have to say tasted that I like it the best is Tillamook.
Yeah, that's
Tillamook
really
ice cream
good.
is absolutely delicious.
What does that say?
Have you ever had Tillamook best time?
That's my favorite.
Okay. Yep.
Do you want me to get like just plain vanilla?
Or like.
I think they make that mixed one with
I know
chocolate and vanilla.
Oh yeah, do the mix
That-
with
yeah, it's like
chocolate
half and half.
Is it
Chocolate
chocolate
and
big?
vanilla?
Yeah, I
I
got
know
chocolate,
chocolate.
half vanilla, yeah.
Okay.
Yeah, they're pretty. Like you'll see them. Like they're
I'm gonna just chocolate bars.
I love, yeah.
pretty sizable.
Actually, I like drumsticks because I'm still getting my drumsticks. So there you go. Kaylee, have you ever had drumsticks?
Yeah.
Those are so. Yeah,
We
with
did
the
it with
little
the
chocolate
chocolate
thing at the bottom of the cone. The chocolate.
Yeah, that's
I really I hated that part as a child.
What? That was the best part.
I don't like it. It's just
Well,
And it melts by the time
Yeah.
you're down.
When's this all due?
Thursday's the test.
And I heard Friday. That's what I heard.
Oh,
Okay,
read here.
it's Thursday.
Thursday's the test. So 4
Read
and
here.
5 are today's stuff. There's nothing actually assigned tomorrow because we're doing the volume of the bananas. Wednesday's assignment is the review assignment, but I would spread it out. Like I would wait until Wednesday so you have time to ask questions. Okay, definitely make sure you go back through your quizzes and that you can answer all of the questions from your quiz. And then all we've done is uniform cross-section and arc length. Arc length is all algebra. Uniform cross-section, I told you guys last week. For uniform cross-section, it will be just like the very last page on your quiz. I'll give you the same region, and I'll ask you to write the equation if your uniform cross-section are squares, if the uniform cross-section are equilateral triangles, if they're circles, semicircles, like that kind of thing, just so that you keep setting it up, because setup is definitely the most thoughtful piece.
So are we just gonna set it up and not solve?
There will be like one
That's
where
like
you'll
okay.
actually solve. So on your quiz, the whole back page was set up but not solved, but then somewhere else in the quiz that we're
Yeah.
actually solving. So
So
the
the
same
back
kind of thing.
I was gonna say that's like.
And so we're gonna do.
the
So
first
since
two assignments. For
Yeah.
that. That was like that.
this is the test, are we going to have a full page of set it up for cross sections and like they're gonna be mixed in with each
Yep,
other?
there's, well, no. I mean, there will be a separate, like, these are all cross-section problems. These are all volume by rotation problems.
You can't do it any other way.
And the other assignment that I did not write up there is Wednesday during class, we will do an actual AP question, and that will count as a separate assignment, but we'll do it during class and grade it.
What day is that?
Wednesday. So I obviously, for test, I would like to do that.
I have a question. Yeah. So like on the AP test, like if there's this algebra problem and we're like running out of time, how much is like all the algebra like worth? Like to get that final answer?
It depends. So normally you get a point for limits, a point for the integrand, and then that's why when you guys don't write them, I mark you wrong.
Didn't they give us the limits?
That's how I feel. And then the remaining, like, so out of 4 points, 2 of them will be the finishing piece.
Okay. So you can still get like even though they
But
two out of
sometimes you might only get 1 out of 3, 1 point for setup, and they'll incorporate the integrand and the limits as just a single point.
Oh,
So it
constancy
depends.
driven F, you,
They vary. So either 1 out of 3 or 2 out of 4, depending.
Okay.
wow. It's rough.
Okay. So.
As if this was all the.
All right. So everybody's got their stuff going for tomorrow for our volume.
I can't be busy after all the other
No, that's untrue.
That's why it would have been 1 to 5 instead of 0 to 8.
Is that not true? Oh, yes.
That's what that was the
Can't do it.
It would have been
That's
5.
untrue. Worst case scenario, you take off the bottom of that and use this. That's what I do, like realistically.
Worst case scenario would be with ends.
Worst case scenario, you beat.
Okay. Okay. New one.
Worst case scenario, you don't have ice cream. I think that is worst case scenario.
Ice cream for ice cream. Yeah, use your shirt.
Should we stop the recording?
Oh. Probably. For some reason I was thinking, I was like, wait, is the whole thing on the whiteboard?
I don't know her password.
I forget it. Oh, it's like, it's something like really easy. It's like,
It's just cold.
It's like something like that. Oh, yeah.